Switchgear refers to the combined electrical equipment used to make, carry, and break electrical circuits in a power system. This includes devices such as circuit breakers, fuses, contactors, relays, voltage transformers, and current transformers. Types of switchgear: low voltage, less than 1000 VAC, medium voltage, 1236 kVAC, high voltage above 36 kVAC. Switchgear is also categorized based on the type of insulation used, which can be air, oil, or gas. Our focus here is on gas-insulated switchgear. Gas-insulated switchgear is a type of electrical switchgear where most components are enclosed in gas-filled chambers. The primary gas used in GIS is sulfur hexafluoride SF6, which provides superior electrical insulation and arc quenching properties compared to air. This allows GIS to have a significantly smaller size and weight, making it ideal for confined, indoor spaces where high voltages are needed. The design of gas-insulated switchgear involves using a dielectric gas, typically sulfur hexafluoride SF6, to insulate various switchgear components within grounded, metal enclosures. The gas is maintained at a moderate pressure of 400 to 600 kilopascals to prevent leakage or condensation at low temperatures. SF6 is a colorless, inert gas that is approximately 5 times denser than air and provides 2 to 3 times better insulation. Its superior arc flash handling capability makes it about 100 times more effective than air. GIS components are pre-assembled and gas-filled at the factory, simplifying the installation process. The working principle of gas-insulated switchgear is based on using a dielectric gas, such as SF6, to insulate electrical equipment. SF6 offers several advantages, including excellent thermal and dielectric properties. GIS systems operate using a combination of vacuum and gas to isolate live parts. This design makes the switchgear highly compact and efficient, providing excellent reliability and low maintenance requirements. During arc flash quenching, SF6 decomposes, but the decomposition products typically reconstitute back to SF6, allowing the gas to remain effective over a long period. Gas-insulated switchgear has been evolving since the late 1960s and has become increasingly popular due to several key advantages. GIS switchgear is highly resistant to environmental conditions like moisture, dust, and salt air, which enhances its reliability and uptime. This makes it suitable for harsh environments such as coastal or desert areas. The components of GIS are sealed in a gas-filled enclosure, preventing exposure to the surrounding environment. This significantly reduces maintenance requirements since regular testing and inspection are not needed. GIS eliminates the need for air insulation, allowing it to be much smaller than air-insulated switchgear. This compactness is ideal for areas with limited space, such as indoor or urban settings. By enclosing components within modules, GIS prevents arc-causing incidents like vermin entry or conductive dust accumulation. This reduces arc flashes and increases overall safety. Additionally, SF6 is an excellent arc-quenching medium. GIS comes pre-assembled, making the installation process straightforward and quick. This leads to easier installations and shorter installation times. While gas-insulated switchgear has numerous advantages, it is essential to be aware of its limitations to make an informed decision between GIS and other types of switchgear, such as air or oil-insulated variants. The main drawbacks include high cost. One of the major disadvantages of GIS is its high initial cost compared to other types of switchgear. However, the long-term benefits, such as minimal maintenance, can offset the initial investment. Longer outages. If GIS experiences an internal fault, the sealed nature of the equipment can lead to longer repair times. Gas-insulated switchgear is commonly used in high-voltage applications like transmission and distribution and in medium-voltage settings such as substations. A gas-insulated substation offers benefits like a reduced footprint and high reliability. GIS is also gaining popularity in industrial and commercial properties. Its compact size makes it ideal for indoor or confined spaces, requiring significantly less space than conventional air-insulated switchgear. Additionally, GIS is suitable for underground installations, making it useful in areas with limited land space or specific environmental concerns, such as adverse weather or soil conditions. Common failures. GIS can fail due to SF6 gas leaks, excessive microwater in the gas, or component failures. Regular testing and maintenance are crucial to ensure safe and reliable operation. Users need a maintenance checklist to prevent failures, optimize performance, identify issues early, minimize outages, and extend lifespan. Annual checks and condition inspections every 5 to 10 years. Includes voltage withstand tests, contact resistance, relay operation, and other parameter checks. Components are usually lubricated for life, but occasional oiling may be needed after many years. May involve breaker replacement, SF6 gas removal or recharge, and other updates. Manufacturers provide specific maintenance guidelines, including frequency and procedures, ensuring the switchgear remains in good condition. Gas-insulated switchgear versus air-insulated switchgear. While both GIS and AIS serve similar functions, they differ mainly in their insulation mediums. Insulation medium, GIS uses gas, typically SF6, for insulation. AIS uses air for insulation. Advantages of GIS: compact and efficient. GIS is more compact and efficient, ideal for confined spaces. Construction: GIS components are housed in gas-filled, earthed modules, sealed for life. AIS components are generally accessible and withdrawable. Installation: GIS often comes pre-assembled, making it easier and faster to install, especially in remote or space-constrained locations. Maintenance: GIS requires minimal maintenance, unlike AIS, which needs regular upkeep due to exposure to environmental elements. Reliability: less susceptible to environmental conditions, making GIS more reliable in harsh environments. Higher initial cost: GIS tends to be more expensive upfront, 10 to 40% more due to its construction and use of SF6 gas. However, the long-term savings on maintenance can offset the initial investment. Applications: GIS is suitable for high voltage and medium voltage applications, urban settings, and areas with limited space. AIS remains valuable where initial cost is a major consideration and space is not an issue. Let us discuss main topic. Hybrid gas-insulated switchgear. HGIS offers significant environmental benefits by reducing SF6 gas consumption compared to traditional SF6 gas-insulated switchgear. GIS at the same voltage level. Here's a more detailed look at these benefits. Reduced SF6 gas consumption. HGIS can save up to 2/3 of SF6 gas consumption compared to conventional GIS. This reduction is achieved by combining gas-insulated components with solid insulated busbars, which eliminates the need for SF6 in certain parts of the switchgear. Environmental impact. SF6 is a potent greenhouse gas with a global warming potential GWP 24,300 times higher than CO2. By significantly reducing SF6 usage, HGIS helps lower the environmental footprint and mitigates the impact on climate change. Operational efficiency. HGIS systems are designed to be modular, making them easier to install, maintain, and upgrade. This modularity also allows